Good morning, friends. Today we are discussing problems on continuity equation. The statement of the problem goes like this. A pipe 200-meter long slopes down at 1 in 100 and tapers from 600 millimeter dia at higher end to 300 millimeter dia at the lower end and carries 100 liters per second of the oil. That is, the discharge through the pipe is that in 1 second 100 liters of oil is flowing, and it is given that the specific gravity of the oil is 0 0.8. If the pressure gauge at the higher end reads 60 kilonewton per meter square, uh, s- uh, neglecting the losses, you are asked to determine what will be the velocity at both the ends and the pressure at the lower end. So here, so this is the higher end and this is the lower end. So here the higher end, it is said that the diameter is 600 millimeter, and in the lower end, so the diameter is reduced to 100 millimeter. So, and it is said that the slope is 1 in 100. So that is for 100 meter if I go horizontally, so I am going 1 meter vertically. So now, the diameter of the pipe at the higher end is given that D1 is equal to 600 millimeter, that is 0.6 meter. So, the area is now at the higher end, it is pi d square by 4. So, we are getting area here. So, diameter of the pipe at the lower end, that is here, D2 is equal to 300 millimeter. So, that is 0.3 meter. So, area of the pipe at section 2 is now pi d square by 4. That is what we are getting here. So height of the pipe at the lower end, so that is above the datum. So datum line is here. So the pipe is exactly at the datum line at the lower end. So my z value is 0 there. So that is at section 2 my z value is 0. So z2 is equal to 0. It is given that rate of the oil flow, that is discharge, is 100 liters per second. So 1000 liters is 1 meter cube. So for 100 liters it is 0.1 meter cube per second. So pressure at the higher end, P1 is given as 60 kilonewton per meter square. You are asked to find velocity at both the ends. That is at both these two ends you need to find out the velocity, and it is asked to also asked to find the pressure at the lower end. So that is P2 to be found out. So P1 is given. So velocities V1 and V2, the first question to be answered. So now we know that discharge is nothing but the product of A into V. So whatever volume of fluid enters at section 1, the same volume of the fluid is leaving at section 2. So my Q is equal to A1 V1, that is equal to A2 V2, where V1 and V2 are the velocities at the higher and lower end respectively. So my V1 is nothing but the ratio of Q by A1. Similarly, V2 is equal to Q by A2. So now we know the discharge. So that is it is given that it is 100 liters per second here, so that we are going to substitute here. So Q and A1, that is the area of the pipe at section 1, A2 the area of the pipe at the section 2, that is calculated. Substituting them, we are getting the velocities V1 and V2. Now pressure at the lower end P2, so to be calculated, that is at section 2, what is the pressure to be calculated using Bernoulli's equation. We have the sum of the three heads, that is pressure head plus kinetic head plus datum head is the sum of the three heads, that is pressure head plus kinetic head plus datum head. So here at section 1, so that is the higher end. So if the slope is 1 in 100, that is for 100 meter of the length, so the height is 1 meter, and it is given that the length of the pipe is 200 meters. So for 200 meter, so the height of the pipe from the datum line, so that is from here to here, So Z2 value is 2 here, so that we are going to substitute here. Whereas at the lower end, so the axis of the pipe is exactly on the datum line. So there will be no height here. So my Z2 is 0. Whereas from here to here, so the height of the pipe, that is the axis of the pipe at the section 2 from the datum line is 2 meter, because it is said that the slope is 1 in 100. So for 100 meter length, so the height is 1 meter. So for 200 meter, it is 2 meter. So that Z2 is substituted, Z1 is substituted as 2 meter here. Solving the equation for pressure at the lower end, we are getting P2 is equal to 74.8 kilonewton per meter square. Thank you.